So this is a question that may have never occurred to most people, and it had never occurred to me really to question it until I had reason to. So why is false less than true? Well, one answer would be just the fact that it is, because we map false to 0 and true to non-zero. This happens to be true, but I don't think this is the real reason. If I were to ask another of my programmer friends, I might get an answer which was mathematically sophisticated, but to me, not that helpful. So I thought about this question, and I thought, let's take a step back. Imagine we had no Boolean value ordering. How would we define it? In fact, I might get behind not defining it, but how would we define? Because true and false at the end of the day are just labels. High and low signals are commonly either way round. We can label the truth tables any way we want for Boolean algebra. But let's say we want to define it. Okay, so quite often we can gain insight by trying to generalize things because we see a small part of the picture that's very specific. If we step back, we can ask true and false are values, but if we generalize them, we could make them into functions. In fact, we could make them into predicates, right? And here they are as predicates. And these are, we can make these predicates do everything that we know true and false does. They behave in a Boolean algebra just the same. But now we have a bit more generalization. We can think about these as two ends of a predicate continuum, right? So true is on one end, always returning true. False is on the other end, always returning false. And in between, we have predicates that sometimes return true and sometimes not, right? A and B are somewhere in between that true-false continuum. Well, so what does it mean for one predicate to be ordered with another in this continuum? Well, the obvious thing it would mean would be things that it returns true, the set of things that it returns true for is larger than another predicate set of things. That would mean that one predicate is larger than the other. Or, one's a subset of the other. In pictorial form, we think of it like this. So the predicate B would be less than A if the set of things for which B returns true is smaller than or equal to, less than could be the subset. And we could have less than or equal to, right, if they're not a proper subset. And in this form, true would be everything, right? And false would be a point, right? That's the empty set. So false is less than everything, and true is greater than everything. And this is quite a pleasing interpretation. And it sort of has a natural extension to an intuition for Boolean implication. So here's the truth table for Boolean implies, right? And it implies is a Boolean operator, just like and or. So it has a truth table. And we can say A implies B is a proposition whose truth depends on the values of A and B. This is the truth table. One of the things about this truth table is you can see that false implies anything, right? The first two lines of this truth table. If A is false, B can be anything, and the proposition A implies B is still true. And it's hard to think as humans about false implies anything. This is a hard intuition to have. But if we think about it in terms of sets, it's much easier. In those predicates, B implies A because everything that B matches also A matches, right? And this is the part where B doesn't have to be a proper subset, but the diagram is clearer if it is. And so now expanding to the full diagram, we can see that false implies anything because it's the empty set, right? It's less than everything. It implies everything that is true for the predicate false, which is saying nothing, right, is also true for any predicate. Okay. Now, what this means is that if C++ had an implication operator, we'd presumably spell it like this. And it would actually mean this thing which seems unfortunate at first, which is when you actually have Boolean values, A implies B has the same value as A less than or equal to B. And my thought on this is like we just have to train ourselves not to like operator spelling. These operators are completely different. And we have other situations where like we wouldn't say A arrow B has anything to do with B less than minus A, right? And like the spaceship operator is not a palindrome. Think if that surprises you, think on it. Anyway, I had reason to go down this rabbit hole. This is one high school mathematics explanation of why false is less than true. It's consistent with Boolean algebra, set theory, and all those things. And I hope this gave some of you an insight into that and into implication. Thank you very much.